precise grooves which are kept sealed. That is where the other cost aspect is. They keep it sealed until it is ready for use so that it doesn't get damaged in the interim period from casting to usage. There also I learned for the first time the prefabricated cages. You can see the cage with the full pier cap and also the full height pier casting on an urban metro. This I don't know whether we still practice here. Pune ones I find it, the ones which I am seeing in construction looks to have multiple joints or multiple poles. They are not very well aligned, at least the shutters don't give me. So after this one job took a great amount of my time and one of the biggest job I handled there, and others were relatively smaller, and in between them I also managed to get a chance to work as a proof checker for an arch, spandrel arch bridge, a multi-span spandrel arch bridge. And this arch bridge in Malaysia, please understand, they also use a lot of precast spun driven pies. They don't use board castings too much. So this had these driven pies. They can be raked in any direction, and with that, these are 800 mm diameter. The grade of concrete, because of the spinning process during the production, is almost 60 to 80 grade. They get very dense, and they are also pre-stressed, so that when you drive them with high energy, the rebound tensile stresses do not lead to cracking in the concrete. So this is another technology which I know only one project where it has been used, which is the jetty for in Gujarat. They had about 40-meter long sites which cast and installed because of the sheet. But this is commonly done in every bridge site there. The construction of the arch itself, the shallower ones were built by temporary towers, stayed and with slip forming, horizontally slip forming equipment, and the deeper ones built by staging. So what I got a chance to see all the different methods of arch construction in one project. So that was another exciting learning experience for me. Another bridge in the same package was a straight bridge which was done by incremental launching. You can see the process going on here. To understand incremental launching, the example in India is Panvel Nadi, bridge of Konkan Railway. It is suitable for straight alignment, level bridge, and if it is curved, it has to be circular curve, and combination of vertical and horizontal curvature is very difficult. It's practically impossible and it's avoided. So basically the idea is you cast pieces of the structure on shore, and with the attachment of the launching nose, push it forward one piece, then you cast the next piece, push it forward. So incrementally you build this bridge up. The disadvantage of this bridge is, the disadvantage of this bridge is, imagine this section right now. This is section sitting on top of the support. At one time, this cantilever will, just before touching, will be the very long cantilever. So this will be a negative bending moment point. As you cast and push it forward, the same section will come to mid-span next. After some time, it will become support again. Then again mid-span, again support. So every section will continuously see changes in the design forces. So you need to have a good way of developing the pre-stressing layout using a combination of temporary and permanent pre-stresses. So this is a very involved design which you get to do. Of course, as I said, this is a very specific location where you can use it. So this with pre-stress concrete is done in this bridge where I worked in Panvel Nadi there. But steel, it's relatively simpler. One of the incrementally launched steel bridge is the final rail deck of Chennar Bridge. Another time, another place you can have a look at that work going on. So this is about the end when I decided that for personal reason I had to come back to India, and I shifted back to Chennai. At that time L&T Rambol was just formed, and Chief Executive of L&T Rambol was Mr. Raghavan, an ex-2 guy, my boss for 8 years since 2. He had left to L&T and he was the Chief Executive. He said, don't look for job anywhere unless I tell you I can't employ you. So still went for an interview. 2 hours interview, said okay, we'll take you. So that was in 2000, and joining that, one of the first job that we did was the Lajpat Nagar. It was a fully curved box and single cell, 2 independent carriageways, as you can see there. The negative cables were all cut, and it's a 4-span continuous structure. The negative, I cannot move the slide here. The negative cables are all laid in the slab, and the intermediate blisters, the soffit are all in the soffit with soffit blisters. So these are all actually made to make the construction easy, because the concreting with this, the mold was inside, concrete could be only poured, it has to go past all this, which means that we couldn't run a cable through the web. So the positive and negative bending moments were with a family of overlapping cables which are only straight. That's how this was managed. So the detailing helped in casting of this segment. It made the segment casting easier and therefore the construction faster. Now this project, this project is actually 153 bridge projects in Karnataka. The reason why I like this project is because it put up another challenge. The 153 bridges were to be finished in 3 years, and they were scattered on about 9 or 10 districts of Karnataka. It was an NABARD funded project, and it was divided into 3 packages. The package which I worked with L&T had 39 projects, the bridges, and the problem was the bridges were not very big bridges. They were all 6 meters, 9 meters, 20 meters, and they were scattered across 3-4 districts, the farthest bridges being almost 300 kilometers apart. How to do 39 bridges in 3 years? The question was, one way to do cast in situ. That means you need more or less, let's assume that one bridge site was finished in 6 or 7 months or 10 months. So that means 36 means 3 bridges, so you need to tackle 10 sites simultaneously, 10 construction team, 10 batching plants, 10 supervision, 10 quality control. It was going to be a nightmare. So they decided that they don't want to do that. They would like to do all of it factory produced precast elements. So they decided was that you will factory produce it in Bangalore, you will transport it. Now comes the question, these bridges are all scattered, none of them are on state highway. Only one of them was in state highway. Others were all rural roads and major district roads, which means that suddenly you will find a 90-degree turn on the road. So you can't transport big concrete pieces. So the condition given to us as designers was, you break down the bridges into components. No component should be more than 6 meters long. No component should weigh more than 9 tons, so that it can be transported in an ordinary truck. So only other thing you should do, parapet should be precast, leg slab should be precast. Where 20 meters span, the eye girders were precast, but 20 meters could not be transported, so they were broken to 3 segmental. So segmental eye girders have also been developed for them. Precast pier cap, precast abutment cap, all that has been incorporated in one project. It was not a financial success, it was just a break even. The reason was for the factory the volume was too small. Maybe a 200 bridge package etc. would have been more profitable. Okay, so this is a problematic one because previous slide, okay. Okay, I come back here. Okay, so the in situ footing is done. Then the precast column. Notice the small area of the column at the bottom and the dowels. Then the in situ stitch so that the abutment columns are stitched. Then precast planks are slid into grooves. There are grooves in the columns. So this precast planks are so that it forms the front retaining structure. Now because the height from ground to road level will be different, the wing walls are cast in situ. So you see the cast in situ wing walls built. Forget about the season. The precast abutment cap is placed, cast in situ dirt walls. So abutment is ready. Similarly footing ready, precast columns, in situ stitch of the column, precast pier cap in 2 pieces. Then the stitching is done here and the 2 columns. Then the deck planks are placed, 100 mm screed is laid, precast parapets are involved and the bridge gets ready. And this is an example of a finished bridge. Actual, real photograph of the one. So, incidentally, as a part of the government's precasting policy, it's going to become mandatory that another couple of years that 50 to 60% of bridge component must be factory precast. Let's see how that policy works out, because I can tell you in the 6 years I worked in Malaysia, not even one contractor cast a single girder. Design was done individually, they were ordered and they were delivered to the site. Pure design. Nobody puts up their shuttering, nobody, but in India everybody has its own shutter and crane and things like that. So with that, quality becomes very good. Then the next bridge which I worked on was the first cable stayed bridge in my life. I used to worry, when will I ever get a chance to do a cable? It came up in this form. It's also a very peculiar situation. It's an ROB. An existing 2-lane had to be widened to 4-lane. And also the question was tight. The space was so tight, like the one which he showed in Santra Market. We didn't have space for 2 pylons. I mean 2 parallel pylons, 2 columns. There was not enough space, just for one central one. Then the question was, unlike Bardhaman, we couldn't do both the decks together, because one lane had to be maintained. So when we were into the fix, so we said, okay, we will devise a 3-plane one in which the central cable will serve for both the deck one, but we will cast it in phases. We will cast one carriageway first, open it for traffic, then demolish the other one, build the next one and integrate. This decision was fine, but then it led to the problem that the adjacent bridge were too close and the Patna soil was not very, stiff in that location. So major truck vibrations were getting transmitted to this deck, and the casting for designers' convenience and for construction, we made the full deck in situ. There was no problem with that. Put staging, while the trains were operating below, staging could be cast. The only difference was the structural depth between the top of road and the bottom of the girder was only 600 mm. So we have used the concept what he mentioned, the semi-through type of beam. The edge beam was, majority of the strength was above the deck. So that was done. But then the question was, when the second carriageway is integrated with it, the central anchors, they will connect and they will have dowels. And there should be no vibration when the concrete is setting. We were finding it very difficult to ensure, because there will be live load on this left for the second one, and when the edge beam is cast, then they will be able to thread in and do the bolting for it, and in a small short blockage of time when there will be no traffic around, so that at the time of bolting there is no vibration to upset the setting. So you engineer solution to your problem situation. Then finally, not finally, the one major thing is the wide decks on single column, this so-called spine and wing construction. This is not the first one in the country, this second one, but it is the largest of its type at that time. The previous example was the JJ flyover, where the deck width was around 15 meters, done by MSRDC in the 99-2000 period. So by the time it came to 2008, for the new terminal T2 in Mumbai, they needed a 27.2 meter wide deck to be on a single column, with the traffic of 4 lane of traffic operational during the construction. The question was, could we transport this 27.2 full width casting? The answer was no, because the right of way available was only 30 meters. So at some stage, when you may be able to transport the segment like this, but at some stage you have to turn it. When you turn it, it will block the full width. And you needed to maintain the 4 lane, because this was the only, or I should say, one of the major access to the then operational international terminal of Mumbai airport. So it was decided that you can't make the full cross section, so the cross section had to be divided. So the cross section was sliced into 3 parts: a central spine and the 2 sides. So that is what it looks. Sorry, I went wrongly. So that is what it looks like this. If you see in this picture, this is a spine portion which is 9 meter wide, and these are wings, we call it. They are also 9 meters wide. So you can imagine a 9 meter cantilever attached with transverse distressing, and the majority of the line load is flying on this. And then thereafter, with 2 rows of bearing, they go into this. And in this picture, you can see that the spine, which is a match cast segmental construction, the erection is going forward, followed by the system of trolleys which erect the wings. And when the wing lifting is going on, traffic continues to fly at the bottom. Today, maybe in 2008 to 2014, this was the first of this width, but subsequently we are in 22. So in the last 10 years, another maybe about 40-50 kilometers of such have been built, the widest of them being almost 34 meters wide. So this technology has caught on, and it was a good thing to work at that time on a project of this nature. Then moving on to the next is something that again has caught on very widely in our country. It is strutted boxes. I am not saying they are not done, but the external strutted box was done for the first time of this magnitude for very small box, and to appreciate that you have a look at it. The Nasik corridor is 5 kilometers long. As you can see in this cross section, this is a very small box with an external strut, segmental construction and erected and launched over this. The reason here the full 20 meter could be cast because the ROW was very wide. It was almost 70 meters wide. You could almost turn it around without obstructing the traffic below. The two-side national highway traffic had enough space to fly. So the decision to do whether full width or to do partly depends upon the ROW. Most of the river bridges that are built with wide deck have the full width segment casting, whether it is second Vivekananda bridge, extra dose bridge, or the Kachi Dargah's extra dose bridge, or even Samaria's or Ganga bridge. Every one of them are full deck width casting, single pole. Okay, because in river there is no ROW issue. The whole side is, you are not obstructing traffic at all, so you can transport them. But when you do it in urban environment, these become the consideration. So some place we are able to do, some place we are not. After doing this, the next project is the double decker in Nagpur. So I think most of you know about it. Basically it was like an afterthought in terms of attaching a road deck to an already conceived metro pier so that we don't have too many foundations in the city. And today this idea is being extended to do 2 levels of roads, and some of them are likely to come up in near future. But this double-decker metro road in urban areas will become very widespread. Maybe another 1 corridor is coming, or 2 corridors are coming up in Nagpur, if I am not mistaken. And other cities have also started to look at it, because in urban area the biggest problem is we have multiple requirements for space. We have a mass traffic transit requirement, we have a local traffic requirement. Both of them are required. So therefore, the same space available is the same. Land acquisition is practically impossible now, considering the laws that we have for it. And the only problem with this is the kind of construction equipment that you have to design, and that you can appreciate is this. The 2-level one in Nagpur was built with a launching girder which had dual system. For the lower level you could feed the segment from the bottom. But once the bottom is finished, obviously you can't feed segment from bottom, so it needed what is called as the front feeding. So the launching girder are specially designed to be capable of feeding the segment for the metro from the front and taking it back. So as you can see, structural engineering is progressing along with the construction engineering is also progressing. And these equipment design currently, a lot of them are imported. I think we need a lot of capacity building in India for managing all this. This is the first extra dose bridge that we worked on. The point of this bridge to show is basically it's a full width segment, 21 meter wide segment casting. But the interesting thing to learn is this actually, if you look at the bridge arrangement, it is integral at the 2 pier, and there is an expansion joint at every alternate span. At mid span there is an expansion joint. Traditionally in law, and the span is also 144 meters, so for 74 meters expansion joint at mid span is generally not a good idea. So old traditional design had been a needle beam arrangement, which is actually a moment transferring come expansion joint. In this instance, we decided that needle beams are little difficult to install and maintain. So we wanted to go for a pure hinge. So what we have seen is an engineering of a solution in which it's a simple hinge. It only transmits shear. It doesn't transmit moment. And it accommodates movement, longitudinal. So the older hinges, hinge is not being done for the first time. The old bridge, like the old Zuari bridge or the old MG Setu, which has been recently replaced by steel trestle, they all had central hinges, but all of them have led to failures because in those days the metallurgy and the installation process were not very well understood and appreciated over a long time. They wore out and finally they ended up being 3 cantilevers rather than a hinge joint. So here it is a combination of patterned PTFE and sliding bearings which we have done. Then we also got a chance to work on an unfinished project of cable stayed bridge in Tapi, Surat, wherein partly completed bridge was dismantled and rebuilt to our design. And then finally the first multi-span cable stayed bridge in our country we'll have many more of them. I am very sure we'll have many more of them. Which was built by a free cantilever method with segment being fed from the water. The interesting aspect of it was that the expansion joint is 610 meters apart. That is, if you look back at it, sorry, the expansion joint, one expansion joint is here and one is beyond the last pylon on the other end. So which means that, and all these decks are integral with the pylon, so which means that they have a lot of accumulated creep and shrinkage deformations that are taking place, and that leads to a very strong foundation, and we need the flexibility of the foundation to accommodate. So it's a dual thing. So to optimize the foundation design, before doing the closure of the segments at the midspan, they were pushed apart. See, shrinkage and creep is all acting inward and it will pull the deformation inward and it will introduce lateral force this way. So what we did was introduce compensatory force in the opposite direction before sealing this joint. Similarly, introduce 250 tons compensatory force in the other end, and finally 650 tons in the center, so that the farthest one get the biggest amount, because that's where the deformation will be the maximum. So each one of these projects give new learning, new opportunity to do something different, and that has been my luck, I should say, that I've been involved and associated with all these projects. So it's been a long, continuous journey of learning, and I hope it's been sustained for a few more years till I become physically unfit. So till that time, I hope I continue to be associated with these kinds of projects. Thank you very much for patiently listening.
Are there any questions for PJV sir?
Brain dead. So much information.
No sir, this was very informative. It was like seeing a movie or something. Are there any questions?
How much amount of live sensing technology is used in Hello, yeah. How much amount of live sensing technology is used in the construction time and also during the life of the bridge?
Okay.
So that I'm just talking about IoT in structures.
Okay, I will put it in another term, but just correct me if I have understood it wrongly. You are talking about what kind of structural health monitoring we do post construction.
Yes.
Okay. Structural health monitoring is just coming into the country. I can tell you the only experience I have had of some kind of structural health monitoring in these projects is the cable stayed bridge at Patna. There are 46 cables, 23 of them have load cells installed in it. And problem what happened in 2013, one of the tension bearings which anchored the deck failed. So from 2008 when it was commissioned to 2013 when the tension bearing, nobody went near the load cells. Structural health monitoring system is supposed to be continuous monitoring. So at least somebody has to have a periodically take responsibility for monitoring. The only project that I know of on which structural health monitoring is continuously being done is the cable stayed bridge at Naini, and that too why? Post construction there are some distress observed, so they have gone back to doing an inspection. And please understand, these sophisticated bridges, it is not just a matter of taking measurement of strains, temperature, wind, etc. You have to do an analysis for it. The analysis for it requires you to have a specialized knowledge for it. So in the case of Naini Bridge, NHA has given a 5 or 10-year contract to COEP, who were the original designers. They have installed sensors. Post the distress, they have installed sensors which measure strain, temperature, things like that. And the data is fed to COEP, who do the, I don't know what the periodicity of the analysis, whether it's monthly analysis or the quarterly analysis, and submit a report to NHA to suggest whether all is well or we have to look for some problem. So now on the other hand, it is catching on for important, especially those who have seen, say for example, we take vaccine shots because somebody close to us has seen the pain of being infected. So similarly, you will see that Thane Creek Bridge, they had a painful first experience. They didn't have so painful an experience the second, but they are not very still happy from what I hear from the long term. So for the third Thane Creek Bridge, they have commissioned, or they are going to commission a structural health monitoring system which will measure temperature gradient across the section. It will measure wind. It will measure strains. It will measure all kinds of things on a live continuous there. You have to understand also this technology is improving every day. I mean what we had 20 years back, and the so-called buried strain gauges are thing of the past. Nowadays nobody buries strain. You can install sensors at the top and they don't need energy source. I mean they can be, I don't know what kind of energy source they are talking about. You don't need continuous power, and they keep transmitting the data. You need a data logger which will then, so these are things that are coming. And structural health monitoring is something that we feel is essentially because we have created these assets, we have to maintain and operate them for 100 years at least. So it's not a very prevalent practice now, but it is the coming thing in all these bridges.
So how about bridges in Malaysia? Because
No structural health monitoring that in my 6 years.
I mean, we are not different from others.
In that sense, yes. See, when will we buy safety shoes? Unless we stub our toes on some hard surface, right? Till that time we'll walk barefoot. It's the same way. You have to be bitten once, then you will start taking all these measures. You need to be.
We did have some measures like Savitri River.
Sorry, I couldn't hear clearly.
We do have places like Savitri River Bridge.
Look, you, sir, Savitri River Bridge, you are talking about a bridge built during the British time. Correct. Now question is, none of the data is available. Worst situation is, in the last 20 years, we have created lakhs of bridges. I challenge anybody to have a complete as-built data. Every job it is submitted, but our authorities don't have it. And we are talking about this century. Forget about Savitri, 60 years back, 70 years back. We are blaming things when we were ignorant, but now we are knowledgeable, but still we have not learnt many things. See, we don't, at all stages we must avoid knee-jerk reaction. I mean, one thing happened, next 5 days there will be a great amount of hangama. After that everybody will forget and go back to sleep peacefully. It should not be. It should be ingrained into us as system. It will take time. It will take time because our road authorities have to change the work culture. See, periodicity of inspection is written in all manuals. Nobody does it. You won't believe it, ministry has commissioned an inspection, not I should say more like a survey of all the national highway bridges, and the whole document data is sitting in a server whose access is not available to anybody. It should be public information, no? But it's not. So there is no point in collecting such data also, which will store it in this strong room of a locker which nobody knows the keys to. We might as well have not wasted money collecting them. That's also my opinion, but it will change. It will change. I mean, I have seen a lot of change in my lifetime. You will see much more in yours.
One question about the pre-stressed spun piles which you mentioned.
Yeah.
And so my question is that it showed in a jetty or that.
It was a foundation of a bridge.
Yeah. So is it also there on any other city bridges? Or
Oh yes, urban projects also are all grade separator also all spun piles, driven spun piles. Only thing there will be smaller diameter. That what I showed you was an 800, 900 mm diameter. In a normal grade separator, I have used 450, 500 mm diameter.
And what are the depth of these piles?
These are see Malaysia that way. I don't know whether for a geotechnical engineer it's a heaven. You will see all kinds of problems there to solve. Geotechnical engineers, they'll have a thrilling time working in a country like Malaysia. But for bridge engineers, structural engineers, it's horrendous time. They have very poor soil, peat, soft clays and good soil. So I have seen this driven up to 26, 27 meters, but they are never in single piece. They are all 6-7 meter pieces, then they are joined together and driven to the point.
So what has prevented the adoption of these in India? You said it's not being.
You need to have a strong commitment to quality control. When I say quality control, not in manufacturing, quality control in installation. अपनी पुरानी कहानी याद दिला दूं जो वेइंग स्केल के नीचे से 2 किलो अटैच करके हम लोग चीट करते थे, एंड हम लोग नहीं, वो भी एक मैकेनिज्म था, ठीक है, टू सेल यू लेस एंड टेक मोर मनी फ्रॉम यू, राइट? विथ दीज पाइल्स, with these piles, the driving process has to be professionally done. And that is where maximum amount of cheating will occur. And why I am saying cheating? We don't have professional liability. In our country, we do not have a very strong professional liability. That's why I am saying, I can boldly say we lack professionalism in many respects. We will try to get away with what we can. See, a professional doesn't try to get away with what he can. He does his best. In that country, if you fail and if your project is identified to be failed, you will be out of business for rest of your life. They have such stringent punishment. We don't have any mechanism. A mistake here can change your job, you can change the name of your company, you go anywhere, nothing happens to you. So there is no sense of commitment to that. So that's why these things can be done by those which are companies which are professional and who are very sure what they want. For example, I can tell you, we worked on the Reliance onshore terminal in Kakinada. They used not precast spun piles like this, but they used precast RCC piles for driving on their onshore terminal. That means the KGD6 gas would come there, and there it would be going through the gas liquefaction process. So it's a big plant that Reliance had installed, and the soil was very soft, top 15-20 meters was all clay. So this pile had to be driven through that into the hard strata. The work was given to the kind of organizations which will deliver. If you let it free for all, imagine this bridge is, some such bridge is being done in what the most remote part of Maharashtra where nobody wants to go, where infrastructure doesn't exist. I ask this to be installed there. Who will supervise? Who will ensure that they have done the work? The driving energy calculation I can fudge on a piece of paper and tell you I have driven this. Highways equation, everything is there in the textbook. I will do the formula calculation and prove that this pile has capacity. I can even fudge the test results. So we are scared of that risk. Owners, I am not saying the contractors are scared. The owners are scared of the contractors indulging in these things, thereby eventually ending up, so they don't encourage this. We have a different atmosphere now. I am telling you it will come. It will come in a few years' time. As is our whole industry getting professionalized. It will happen. Anything else? I hope I have not tired you too much.
Sir, the last question from my side.
Okay.
10 years back, we had a visit. When I was a student, we had a visit to Mumbai, where one of the construction was going on. It's about construction cranes.
Construction cranes.
The cranes that they have used for the construction, lifting works and all.
Okay.
Still, we are borrowing it from USA or China or other countries. What L&T or other leading construction companies are doing to manufacture those things in India? Because that costs around 10 to 20% of the project cost.
Okay, this is where it comes back to construction equipment. Today the sector is, unfortunately, the most people who plan out and engineer the construction equipment are structural engineers. You will understand once you talk about cranes, it's not just the steel truss part of it. It is how you operate, how to make it, use it. To give you a classic example, if you have an opportunity, organize a visit to the Mumbai Trans-Harbour Link construction in Sewri, Bombay side. There is a casting yard being operated by Larsen & Toubro, my parent company. They have multiple segment molds. Some of them mechanized, some of them manual. Both of them are in the same casting yard. You ask the construction manager which one he prefers to use.
Mechanized obviously.
Mechanized obviously. And who designed the mechanized one? And who designed the manually operated one? Manually operated one was designed internally by L&T, and the mechanized one was designed outside the country. Why would L&T have this problem? The reason is their design division is full of structural engineers. They have not appreciated this correlationship that in construction equipment you have a very strong component of it. And they don't look at that as a core business. Whereas the companies which produce these molds and things like that, they don't do concrete production at all. They are only producing molds and cranes. Once you start saying on one division I make concrete production at Tane Creek Bridge, on the other side I make mold, you're basically diluting your focus. You are not a focused company. You have a finger in every pie and every finger is getting dirty. So you don't get the kind of improvement that you want to see. There's a problem with our industry. Everybody wants to save small change, and the advantage that you see, there is a similar thing. There's a launching girder. Forget same project, there are 5 launching girders there. 2 of them have been designed by Norwegian rail system, NRS people, the same people who designed the Tane Creek Bridge equipment I showed you, balance cantilever equipment. They design only construction equipment. So they have got one launching girder from there. Talking to the project manager, he said, I didn't even spend one day in worrying about the assembly and movement of the launching girder. I have got 2 designs prepared by L&T's internal design team, for which I am struggling for 6 months to get it commissioned. So my question is, why is L&T trying to do this? If they can't do it, well, might as well get it. The project manager on the other hand says, I don't have the freedom, I am in a big organization, I have a procurement division, I have this design division also. So somebody in the organization asks, you have this design division, why don't you use them, why are you going to NRS? So organizations have themselves their own problems. These are administrative problems. Every organization has. That's a very large organization with larger problems. Smaller organizations have problems at a smaller scale, but they all have this problem. How to balance out the in-house skills with the what they call it, focused external skills. Obviously the focused external skill will also ask for a premium, but he will justify the premium by the savings you get in terms of time, manpower and things like that. So you have only a hint of why we have this problem. You don't have a solution. Solution will come as we progress as an industry.
Thank you, sir.
Thank you, sir, for such a wonderful lecture. With each example and different challenges in every project, India and abroad, we understand that engineering course is truly just an introduction. Our true test or learning begins thoroughly after this course. Our journey as an engineer has shown us, your journey as an engineer has shown us how much we as civil engineers have in store for the future. How a balance of knowledge, experience and presence of mind has to be seen. Thank you, sir, for sharing your experience with us. I'm sure many of us will be walking on your footsteps. Thank you, sir. Our MPSC toppers have arrived. I'll call out their names. I request Mr. P.G. Venkatram sir to felicitate them. Mr. Anuj Rajendra Rani. Ravindra Pratap Singh Jaiswal. Pooja Sherke. Ravindra Jaiswal. Pooja Sherke. Vrishali Patil. Praveen Somnath Birazdar. Sudarshan Godse. And Rishikesh Chirake. Thank you, dignitaries. I request Dr. Sharan Kumar Gaudar to express his gratitude to our guests, dignitaries, and audience with a vote of thanks.
Good evening, everyone. What a wonderful evening. We could hear the lectures of two great eminent personalities, especially PGV sir as well as Yogesh sir. Without wasting much of the time, let me thank the hands which have helped us in organizing this event. First and foremost, let me thank from the organizing committee, let me thank Mr. PG Venkatram for sparing his valuable time and sharing his experience with us. So that was a wonderful speech and wonderful photographs you have collected, that too from 1969, 80s. So that was wonderful collection, sir. Thank you for being here with us and receiving the award from us. Thank you. We need a big round of applause for him, please. I take this opportunity to thank Mr. Yogesh Fangankar, sir, for sharing your experience with us, and 3 projects. They were really wonderful. I hope the many will come. So you'll be a great contender for S.V. Joshi Award too. Thank you, sir. I'd like to thank our director, sir, Professor Mukul Sudhone, for sparing his valuable time and explaining to us why COEP is so great, and we have 1,000 years to achieve the greatness again. Thank you, sir. I take this opportunity to thank our Deputy Director, sir, Professor M.J. Rathod, for sparing his valuable time and spending beautiful moments with us. I take this opportunity to thank Mr. Bharat Gite, President of Alumni Association, for gracing the session and sparing his valuable and things about Alumni Association with us. Thank you, sir. I thank Honorary Secretary of Alumni Association, Dr. S.S. Pardeshi. I take this opportunity to thank Professor M.S. Randive, convener of this function. Thank you, sir. I thank the current head of the department, Civil Engineering, Professor B.M. Dowry, for sparing his valuable time and giving us the constant motivation that we always require. Thank you, sir. I thank the organizing committee members, especially Dr. Avinash Joshi, Professor Madekar ma'am, V.N. Shinde sir, Mr. Sunil Kant, and all other committee members who are constantly working. Since from 3 months we were working on this. So all your contributions are greatly recognized. Thank you, everyone. I thank my faculty members, staffs, and I also thank Mr. Sate, our photographer. I take this opportunity to thank media personnel, Dhananjay Bhagat from People's News, for covering the news for us. I I thank PGV printers for printing the souvenirs for us in a very short period of time. Special thank goes to Seema madam. She was the constant source of working hand for us. She did most of the things for us. Thank you, ma'am. Last but not the least, I thank the audience and my dear students for patiently listening and being here with us throughout the journey. Thank you one and all. We have our family members of the guest speakers, and Mrs. Lime was also here. We thank for them taking their time to stay with us for the journey towards. Thank you one and all. So we'll depart. If possible, we could have a photo session. Outside the photo session. We will have a photo session here. That would be good. So I request everyone to come on the dais, please, so that people will stand here and we'll have a group photograph.